Amanda buys a new car there for 25,000. It depreciates there every year, and here's the graph. And use Amanda's graph to estimate the length of time it will take for the car to depreciate from 15,000 to 10,000. Well, here it is at 15,000. And here it is at 10,000. And what's the time frame there? Well, if we drop down vertically here, 2 and a bit years, and here we have 4 years. So it goes from 15 to 10, from 2, that's 1 box, 2, 3, 4 boxes. So that's 2 and a quarter years, and that's 4 years. So that's 1 whole year and 3 quarters. So it's going to be 1 3/4 years. Part 2 there. Continue Amanda's graph to find the approximate value of the car after 7.5 years. So we just kind of draw on this bit wee slope here, and after 7.5 years we're here. And what's the find the approximate value? Well, the value is here on the y or vertical axis, so we're going back along this line here the whole way over till we hit here, and we have 5,000. So after 7.5 years, the graph suggests that the value of Amanda's car should be about 5,000. Then we're asked what name is given to the type of curve. Well, the type of curve is exponential. And now things get a little bit more tricky. Part B. On the day that Amanda bought her car, remember she bought her car for 25,000. Her friend Cahill also bought a car, and his cost 22,500. Amanda's car will travel 15 kilometers on a litre of fuel. Cahill's car will travel 10 kms on a litre of fuel. How many kilometers will the cars have to travel until the cost price of the car plus the cost of the fuel are equal for the two cars? So after a certain amount of kilometers, both cars will have travelled the exact same amount of kilometers. And after that amount of kilometers, we'll let k equal the number of kilometers. And after this amount of kilometers k, the price of the two cars plus the amount of fuel spent will be equal, right? So Cahill bought his car for 22,500, and for each kilometre his car only does 10k on a litre of fuel. Now a litre is 150 per. A litre of fuel is 150, and that's 10k. So we can see that for Cahill, 10k is equal to 150 in petrol costs or diesel or whatever it is. So 1k will equal this divided by 10, which will be 15 cent. This is for Cahill. So that's the price of his fuel. 1k equals 15 cent. For Amanda, that's going to be a different price per kilometre, because for Amanda, she gets 15 kilometres for every 150 spent on fuel. If we divide both sides by 15, we get 1 kilometre equals 10 cent. Dividing both sides by 15. So for Amanda, each kilometre costs 10 cent. So looking back here again, I'll just bring this down here. Cahill's price after k kilometres is going to be the price of the car plus the number of kilometres multiplied by the price in fuel for each of those kilometres. And remember, for Cahill we worked that out to be 0.15 euro or 15 cent. And that total figure there, we don't know the number of kilometres yet, but we know that this total figure will equal the price of Amanda's car, which is 25,000, plus the same number of kilometres, but this will be multiplied by, for Amanda each kilometre will be cheaper, so it will be 0.10. And now we have our equation, and now we can just tidy this up and solve for k. So we have 22,500 plus 0.15 times k, right? It should be a small k, it doesn't really matter. And we can put them together like this. This means 0.15 times k, and here we have 25,000 for the price of the car plus 0.10 times k. These should both be small k. I'll change this into a small k. There we go. And now we'll just have to do a bit of algebra. So subtracting 22,500 from both sides, or the shortcut is throwing this across, and then also we're going to subtract 0.10 k from both sides, or the shortcut is throwing this across, gives us 0.15 k minus 0.10 k equals 25,000 minus 22,500. So I've done a good bit of algebra there in one go, but essentially I've subtracted 22,500 from both sides, so cancelled from the left, and I've subtracted 0.10 k from both sides, and we get this here, and they cancel from the right. Right, so tidying that up, this number minus that number gives us 0.05 k equals 2,500. And then we get 0.0, or we don't. To get k on its own, we divide both sides by 0.05 k. Dividing both sides by 0. And it'll cancel from the left, and we'll have 2,500 divided by 0.05. Bang that into the calculator, and we'll find that 0.05 divides into 2,500 50,000 times. So the number of kilometers, the answer to the question really is how many kilometers will the cars have to travel until the cost plus the cost of the fuel are equal for the two cars. The answer is 50,000 kms. Okay, and that question there was worth 30 marks, so you should have spent approximately in the exam, if you're doing it, 15 minutes.